October 3rd, 2025. At this very moment, numerous spacecraft orbiting Mars are directing their optical instruments toward an anomaly that defies current understanding. This object is expelling 150 kilograms of gas every second, yet exhibits absolutely no recoil. It's akin to witnessing a cannon discharge without any resultant kickback. This fundamental inconsistency was so profound that when initial data reached scientists, they suspected instrument malfunction. However, their equipment was functioning perfectly. Loeb of Harvard University has assessed its alien technology potential at a 6 out of 10 on his scale. Nevertheless, the reason for your presence here is not solely attributed to this rating. Your interest stems from an event 2 days prior, when an individual claiming affiliation with the European Space Agency disseminated information on 4chan. The leaked material was technical, highly detailed, and conveyed significant professional frustration. The author described a formal investigative committee that has unsuccessfully attempted to categorize this object within any known classification of natural celestial bodies. The individual stated, and I quote, "This position is no longer tenable, and the silence from leadership regarding the cognitive dissonance this requires is becoming a serious professional issue." They further discussed chemical compositions that should be scientifically impossible. Specifically, nickel tetracarbonyl, a synthetically manufactured industrial compound, is being emitted from a celestial body believed to be billions of years old. The dust particles detected are so peculiar that a full week of instrument recalibration was necessary before the measurements were deemed reliable. Compounding these issues is a significant mass discrepancy: 33 billion tons compressed into a mere 3 kilometers. The statistical improbability of such a configuration is so extreme that it suggests either our models of galactic formation are inaccurate by a factor of 10,000, or this entity is not merely space debris. However, the situation escalates further. In 26 days, this object will traverse behind the Sun, rendering it completely invisible to all terrestrial telescopes. Upon its reappearance in December, we will be able to ascertain if its trajectory has changed. If such a change has occurred, no natural phenomenon can account for it. A compelling theory has emerged, one that sounds like science fiction but elegantly explains every observed anomaly. This theory posits that the outgassing occurs without propulsion, the chemical signatures are synthetic, and the thermal conditions are impossible under natural circumstances, suggesting an object powered by an internal engine. This engine, it is theorized, is not fueled by solar energy, but by a force originating from the very inception of the Big Bang. Furthermore, this theory is empirically testable, with 2 distinct predictions, both falsifiable, expected within the next 3 months. This object is designated 3E Atlas, marking the 3rd interstellar body ever detected, and the first to prompt scientists to question whether they are observing a comet or something intentionally mimicking one. By the conclusion of this account, you will comprehend the reasons behind the sleepless nights of certain researchers, why its trajectory appears deliberate, why its timing is uncannily precise, and the potential ramifications if the data continues to defy conventional explanations, as the structural integrity of our current understanding begins to fracture, revealing the true nature of this phenomenon. If you are prepared for this revelation, please engage the like button and subscribe, as this narrative is unfolding in real time. Additionally, kindly share in the comments where you are listening from, the current time and your location, and the most extraordinary event you have ever experienced. Chapter 1. The Mars Moment. Something is occurring presently, not in the distant future, nor contingent on the development of advanced telescopes or the launch of specialized probes. It is happening right now. Today, October 3rd, 2025. At this precise instant, humankind possesses multiple spacecraft strategically positioned around Mars. Each of these vessels is engaged in capturing imagery of the same enigmatic object. This object is identified as 3I Atlas, the 3rd confirmed extraterrestrial visitor to our solar system. This morning, at 4 Universal Time, it passed within 29 million kilometers of Mars, representing the closest approach it will make to any planet during its passage through our cosmic vicinity. The timing of this event is of paramount importance. Allow me to elaborate. For the preceding 3 months, astronomers have been observing this object using terrestrial telescopes. The Hubble Space Telescope has captured its image, and the James Webb Space Telescope has analyzed its chemical composition. Numerous observatories globally have meticulously tracked its movement. However, a significant challenge has emerged from this wealth of data: the immense distance. When the Hubble telescope photographed 3 Atlas on July 21st, the celestial body was situated 446 million kilometers away, a distance roughly 3 times that between the Earth and the Sun. At such an expanse, even Hubble's extraordinary optical capabilities can only resolve a limited degree of detail. Today, however, a crucial shift has occurred. The Mars Reconnaissance Orbiter, equipped with its high-resolution camera, is now 20 times closer to 3 Atlas than Hubble was during its observation period. This 20-fold increase in proximity yields a staggering difference in resolution. Where Hubble could discern only a nebulous mass enveloped in dust, the high-resolution imaging science experiment, HiRISE, camera should be capable of resolving features as small as 30 kilometers per pixel. If the object's dimensions are indeed as substantial as some calculations suggest, potentially 5 kilometers or more in diameter, we anticipate observing distinct structural elements, its overall shape, and possibly even surface topography. The European Space Agency is also actively involved in this endeavor. Two of its spacecraft, Mars Express and the ExoMars Trace Gas Orbiter, have redirected their scientific instruments toward the object. The Mars Express spacecraft carries the high-resolution stereo camera, while the ExoMars Orbiter is equipped with the color and stereo surface imaging system. Both of these instruments were originally designed for capturing detailed images of the Martian surface, but for this limited temporal window, they are being utilized to observe something far more extraordinary. Furthermore, a suite of spectrometers is contributing to the observation efforts. Mars Express is equipped with the visible and infrared mineralogical mapping spectrometer, Omega, and the camera for Mars exploration, CM, while the ExoMars Trace Gas Orbiter carries the near-infrared spectrometer, NRS, and the ultraviolet spectrometer, UVOT. These sophisticated instruments go beyond mere image capture. They meticulously measure emitted or reflected light. Specifically, they deconstruct the light spectrum of an object into its constituent wavelengths, providing invaluable data on its chemical makeup, prevailing temperatures, and whether the observed activity is a consequence of ice sublimation or an entirely different process. The officially stated objective is for these observations to definitively answer fundamental questions. What is the true size of the nucleus? Is it rotating, and if so, at what velocity? What does the surrounding dust cloud actually resemble at close range? Most importantly, is this merely an unusually large comet exhibiting atypical behavior, or does this object possess properties that fundamentally distinguish it from known celestial bodies? This presents a critical dichotomy. Based solely on its luminosity when 3 Atlas was first discovered in July, astronomers estimated its diameter could be as large as 20 kilometers. Subsequently, with the influx of improved data from the Vera C. Rubin Observatory, this estimate was revised downward to 10 kilometers. Observations from Hubble in late July suggested a diameter of perhaps 5.6 kilometers. Moreover, some theoretical models, contingent on the reflectivity of its surface, propose a diameter as small as 440 meters. This represents an enormous range, from 20 kilometers down to less than half a kilometer. The disparity is equivalent to the difference between a small city and a large building, and resolving this uncertainty carries significant implications. If 3I Atlas truly measures 5 kilometers or more in diameter, it would dwarf the previously detected interstellar objects by several orders of magnitude. The inaugural interstellar visitor, oumuamua, was estimated to be approximately 100 meters in size, characterized by a flat, tumbling motion through space. The second, 2I/Borisov, was estimated to be around 600 meters, presenting as a relatively conventional comet. However, a 5-kilometer object, possessing an estimated mass of 33 billion tons, is not merely large. It represents a profound statistical anomaly. To provide context, our current models of interstellar object formation posit that smaller fragments should vastly outnumber larger ones. For every boulder-sized object ejected from a distant solar system, there should be tens of thousands of pebble-sized fragments and potentially hundreds of thousands more. The probability of detection is heavily skewed towards smaller objects appearing first due to their sheer abundance. Yet, here we stand. Thus far, 3 interstellar objects have been detected, and the third is potentially 1,000 to 1,000,000 times more massive than the first. This scenario is entirely contrary to expectations, unless our prevailing models are fundamentally flawed. It suggests that the galaxy is not merely sparsely populated with interstellar debris, but is, in fact, teeming with it. Alternatively, the processes responsible for ejecting material from solar systems may be far different from our current understanding, or, most remarkably, this object may not be debris at all. These are the questions that the Mars-based observations are intended to help answer. If the HiRISE camera captures a clear image revealing a 5-kilometer nucleus, the mass estimations will hold true, establishing 33 billion tons as a definitive minimum. At that juncture, the statistical anomaly becomes undeniable. Conversely, if the imaging reveals a smaller object, perhaps a kilometer or less in diameter, the mystery shifts. In this case, a smaller nucleus exhibiting the observed luminosity and outgassing activity would imply that the object is extraordinarily active, expelling significantly more material than any known comet at a comparable distance from the Sun. In either scenario, a critical discrepancy persists. Now, for the aspect that proves most frustrating, we will not have immediate answers. The collected data must be transmitted back to Earth for processing, analysis, and cross-verification. The European Space Agency has already indicated that spectacular imagery is not anticipated from the Mars Express and ExoMars Trace Gas Orbiter. Both spacecraft are engineered for terrestrial observation of Mars, not for distant celestial imaging. At a distance of 30 million kilometers, 3I Atlas will appear as less than a single pixel within their camera's field of view. While they may capture the gaseous halo surrounding the object or perhaps a faint indication of its tail, the nucleus itself will likely remain unresolvable. The high-rise camera represents the primary hope for detailed imaging, yet even its results are subject to an uncertain timeline, potentially requiring days or even weeks before processed images are publicly released. During this interim, the object continues its inexorable journey. By the middle of October, 3 Atlas will have approached the Sun too closely for observation from Earth, its brilliance rendering it invisible due to solar glare. It will reach its perihelion, the point of closest approach to the Sun, on October 29th at 1.4 astronomical units, situated just within the orbital path of Mars. Throughout this entire period, from mid-October through the end of the month, the object will be positioned on the opposite side of the Sun from Earth, concealed and unobservable. This period of inaccessibility spans 26 days, nearly an entire month. Upon its reemergence in early December, as it becomes visible in the pre-dawn sky, we will finally have the opportunity to observe it again, scrutinize its trajectory, measure its luminosity, and confirm whether its behavior during perihelion aligned with that of a typical comet, or if any unexpected phenomena transpired. Returning to the present, October 3rd, the pivotal Mars moment, reveals another dimension to this unfolding story. While the official narrative focuses on resolving the question of size, there exists an additional layer, one that is less concerned with the forthcoming photographic evidence and more with the implications of the data already acquired. It is at this juncture that conventional explanations begin to falter. Chapter 2. The 7 Sins Against Nature. Loeb published an article on October 3rd, coinciding with the Mars flyby. This deliberate timing underscores the significance of his findings. In this publication, he meticulously outlines what he terms the 7 anomalies of 3 Atlas. These are not mere ambiguities or curiosities. They are anomalies, behaviors, and characteristics that demonstrably deviate from the established model of what constitutes an interstellar comet. He categorizes these anomalies into 2 distinct groups. The first group encompasses 4 anomalies that might potentially be explained or mitigated with the acquisition of more comprehensive data. The second group comprises 3 anomalies that, in his estimation, will remain perpetually perplexing, not due to a deficiency in information, but rather due to their inherent improbability, involving trajectories and temporal coincidences that strongly suggest an origin beyond random chance. Let us commence with the first category, the seemingly explainable anomalies. Anomaly 1. Size. We have already touched upon this aspect. The apparent diameter of 3I Atlas exceeds 5 kilometers, yielding a minimum estimated mass of 33 billion tons. This renders it 1,000 to 1,000,000 times more massive than the 2 preceding interstellar objects. The potential for explanation here hinges directly on whether future observations, such as today's Mars flyby, will either confirm or revise this figure. Should the nucleus prove to be smaller, the anomaly's significance diminishes. However, if the estimated 5 kilometers or greater size is substantiated, the statistical conundrum intensifies. Anomaly 2. The jet. Images captured by the Hubble Space Telescope reveal a peculiar feature, a jet of reflected sunlight extending forward, 10 times longer than its width, pointed directly towards the Sun. Most comets exhibit tails that trail away from the Sun, propelled by solar wind and radiation pressure. This jet, however, is oriented in the opposite direction. The proposed explanation suggests that 3 Atlas is experiencing a powerful outgassing event on its sunward side, expelling material that reflects sunlight before being propelled backward. While plausible, this explanation presents a significant caveat. This jet emerged unusually early, at distances where most comets remain dormant, and it persisted with remarkable brightness and duration. A fainter tail did become apparent by late August, but only after the object had moved considerably closer to the Sun. This temporal delay is anomalous, implying that the dynamics of outgassing are not consistent with those of a typical comet. Anomaly 3. Chemical composition. This is where the situation becomes genuinely perplexing. Spectroscopic analyses conducted by the James Webb Space Telescope and the Very Large Telescope have revealed that the plume of gas surrounding 3E Atlas contains a significantly higher proportion of nickel than iron. In typical comets, and even in the preceding interstellar comet 2I/Borisov, Nickel and iron are found in ratios comparable to those observed in the Sun, indicating a roughly balanced presence. However, 3I Atlas exhibits an extreme dominance of nickel. Nickel was detected across all observation epochs, while iron was only identified when the object was within 2.64 astronomical units of the Sun. Even then, the nickel-to-iron ratio remains substantially higher than anticipated. The significance of this observation lies in the nature of nickel and iron. These are refractory metals, meaning they do not readily sublimate or transition from solid to gas at the low temperatures typically found on comets. The surface temperature of 3 Atlas, even in relatively close proximity to the Sun, is insufficient for raw nickel to simply vaporize. This indicates that an alternative process must be at play. Either a precursor molecule, a compound containing nickel, is present and breaks down to release nickel atoms, or the heating mechanism employed is non-standard. In either case, the situation is puzzling. Furthermore, the gaseous composition is also unusual. Most comets are predominantly composed of water. As they approach the Sun, water ice sublimes, becoming the dominant spectral signature. However, 3I Atlas is rich in carbon dioxide. The ratio of carbon dioxide to water is an astonishing 8:1, placing it among the highest ever recorded. This suggests that the object originated in an extremely cold environment, far colder than the regions from which typical solar system comets typically form. Anomaly 4. Polarization. This aspect, while technical, is of considerable importance. When light reflects off dust particles, it undergoes polarization. The degree and direction of this polarization provide information about the size, shape, and textural characteristics of these particles. Every comet and asteroid that has been subjected to study falls within a predictable and consistent range of polarization values. 3 Atlas deviates significantly from this norm. The polarization data returned results so far outside the expected parameters that the research team initially suspected an instrumental error. Subsequent measurements were conducted, yielding the same outcome. The only viable explanation for these observed values necessitates the presence of dust grains with fundamentally different properties. They are not the typical silicate particles of sand, nor are they water ice crystals. They represent something else entirely. These particles are described as large, complex, highly porous structures, possessing a texture akin to smoke. Herein lies the critical point. These four anomalies, while peculiar, are not necessarily conclusive evidence against the cometary hypothesis. Enhanced data might provide clarification regarding the object's size. The observed jet could be attributed to a rare but natural asymmetry in outgassing. The presence of nickel might be explained by an exotic precursor molecule that is yet to be identified. The dust composition could be a consequence of unusual formation conditions. These scenarios are unsettling, but theoretically explainable. We then proceed to the second category, the phenomena that present as permanent mysteries. Anomaly 5. Trajectory alignment. The orbit of 3 Atlas exhibits an alignment with the ecliptic plane, the plane in which the planets orbit the Sun, to within an impressive 5 degrees. The probability of an interstellar object arriving from a random direction within the galaxy possessing such a closely aligned trajectory, purely by chance, is approximately 0.2%, or 1 in 500. While rare events do occur, this represents the initial significant red flag. Anomaly 6. Arrival timing. This is where the statistical improbability escalates dramatically. 3 Atlas not only arrived on a trajectory aligned with the planetary plane, but also did so at a time that facilitates close encounters with Mars, Venus, and Jupiter. Specifically, the object is passing Mars today, October 3rd. It could have reached Venus with minimal course correction in July, and it is positioned for a relatively close pass by Jupiter in March of 2026. The probability of an interstellar object randomly arriving on a trajectory and at a time that permits such multiple planetary encounters is approximately 0.005%, or 1 in 20,000. Consider this for a moment. If one were to design a spacecraft intended to visit multiple planets within a solar system, the optimal trajectory would involve intersecting their orbital paths. The arrival time would be carefully chosen to coincide with the planet's positions, thereby minimizing the fuel expenditure required for course adjustments. This is precisely the methodology employed in designing human space missions, such as Voyager and New Horizons, where trajectories are optimized and gravitational assists are utilized. 3 Atlas appears to have been deliberately delivered. Chapter 3. The impossible physics. 2 days ago, a significant development occurred. On October 1st, 2025, an anonymous post appeared on 4chan. It was not published in a scientific forum or on a preprint server, but rather on 4chan's paranormal board, a section more commonly associated with internet folklore than with rigorous scientific discourse. However, this post transcended mere folklore. The individual claiming to be the author asserted they were a doctoral researcher collaborating with the European Space Agency. They stated they had ongoing access to the consolidated observational data for 3I Atlas and that they were a member of a formal working group tasked with understanding this object, a group that, according to the Post, had encountered insurmountable difficulties. The quote reads, "For months, I've been part of a formal working group that has tried and failed to reconcile this object's behavior with any known class of natural celestial body. The official position is that 3 Atlas is a uniquely active but otherwise natural comet. This position is no longer tenable, and the silence from leadership on the cognitive dissonance this requires is becoming a serious professional issue for a growing number of us. It is important to emphasize that anonymous posts on platforms like 4chan do not constitute peer-reviewed scientific findings and are not subject to verification. Such posts could easily be elaborate fabrications, role-playing, or the product of someone who has read scientific papers and chosen to instigate speculation. However, several factors distinguish this particular disclosure. The level of technical detail provided is exceptionally unusual. The tone of frustration conveyed by the author appears genuine, and the claims made align disturbingly well with publicly available data, while also introducing context that has not been disclosed in any official capacity. Therefore, I will detail the assertions made in this post, not as established fact, but as a potential insight into the behind-the-scenes deliberations when scientists confront data that defies conventional explanation. The post begins by addressing the object's outgassing. 3 Atlas is observed to be expelling approximately 150 kilograms of gas and dust every second. This is not mere conjecture. It is a measurable phenomenon confirmed by observations from the James Webb Space Telescope and spectrometers at the Very Large Telescope. The object is hemorrhaging material, including carbon dioxide, water ice, and dust particles, in a continuous and violent process. According to the author of the post, this intense expulsion has no discernible effect. The quote states, "It feels like a mistake in the data until you've checked it 100 times with all the available instruments. The object is venting about 150 kilograms of gas and dust every single second. We see it, yet it does nothing. It's like watching a howitzer fire a shell with absolutely zero recoil or smoke or bang. It's a constant violent event with no consequences. And that is a disgusting violation of basic physics. Let me elaborate on why this presents such a significant problem. When a comet releases gas, it experiences a reactive force, a thrust. This is a direct application of Newton's third law. For every action, there is an equal and opposite reaction. The gas is ejected from the surface, and in turn, the comet recoils. While this recoil is minuscule, it is measurable over time. This phenomenon results in what astronomers term non-gravitational acceleration, a subtle deviation from a purely gravitational trajectory. All active comets exhibit this characteristic. Halley's Comet, Comet Hale-Bopp, and the previous interstellar visitor, 2I/Borisov, have all displayed measurable non-gravitational acceleration as they outgassed in proximity to the Sun. 3EY Atlas, however, demonstrates almost no such acceleration. A paper published in September, authored by Richard K. Loeb and Peter V.E., analyzed 4,022 positional observations from 227 observatories worldwide, collected between May and September. They calculated the object's trajectory with exceptional precision and subsequently searched for deviations or residuals, any indication that the outgassing was influencing its course. The upper limit of deviation they found was 0.28 arcseconds over months of observation. This corresponds to a non-gravitational acceleration of less than 15 meters per day squared. For an object expelling 150 kilograms per second, this level of acceleration is impossibly low, practically negligible. The underlying physics, according to the leaked information, functions only if the celestial body possesses a mass vastly exceeding its apparent size. To be precise, it would need to have the mass of a miniature moon contained within a diameter of merely 2 to 3 kilometers. The less complex models indicate a minimum mass of 33 billion tons, which paradoxically introduces a more severe predicament. The statistical likelihood of encountering a mountain-sized object on an interstellar trajectory is astronomically improbable. Consider the implications. If the object, designated as oumuamua, possesses the inertia to withstand the expulsion of 150 kilograms per second of material, it must be extraordinarily dense. Its density would surpass that of ice or rock, approaching the density of iron. A sphere of solid nickel iron, 3 kilometers in diameter, would approximate this mass. However, this is not a metallic asteroid. It exhibits a coma and a tail, actively outgassing like a comet. Therefore, the significant mass must be present, yet somehow coexistent with volatile ices on its surface. The source material further elaborates, stating that their observational surveys have just commenced. Discovering an object of such immense mass so early suggests the galaxy is not merely sparsely populated with cosmic debris, but is, in fact, teeming with such entities. The current models are off by a factor of 10,000. Our fundamental comprehension of what is ejected from solar systems is profoundly and catastrophically flawed. This implies that the object in question is not debris at all. This leads to a chilling and unsettling conclusion that we are being implicitly discouraged from exploring. Pause and let this sink in. If the mass estimation of 33 billion tons or more is accurate, then the statistical models collapse, as large interstellar objects should be exceedingly rare, exponentially rarer than smaller ones. For every rock the size of a mountain, there should be millions of pebbles. Yet, thus far, we have detected 3 interstellar visitors: a small, flat object, a comet of conventional appearance, and now something 1,000 times more massive. This sequence is inverted. We are either experiencing an improbable stroke of luck, or the galaxy harbors a far greater abundance of massive interstellar objects than previously believed, by orders of magnitude. This necessitates a fundamental revision of our understanding of planetary system formation and the processes by which material is expelled into interstellar space. Alternatively, the third possibility is that this object is not debris, but this prospect is even more disquieting. According to the report, the chemical composition also defies explanation. Examining the expelled gases, the situation becomes more problematic. Pure atomic nickel is observed to be vaporizing. This phenomenon is occurring at temperatures where nickel should be solid. This is not a gradual transition, like ice turning to vapor. It is instantaneous. The rate of nickel production is extraordinarily sensitive to solar radiation. Even a slight fluctuation in heat causes it to cease entirely. This behavior is only explicable by the breakdown of a parent molecule. The sole candidate is nickel tetracarbonyl, a compound utilized in industrial refining processes. This compound accounts for all observed phenomena, particularly the absence of iron. However, it is not a naturally occurring substance. The presence of a synthetic chemical on an object believed to have traversed interstellar space for billions of years is deeply perplexing. Nickel tetracarbonyl. Let's consider this for a moment. It is a chemical compound, specifically nickel bonded to 4 carbon monoxide molecules. At ambient temperatures, it exists as a colorless, highly toxic, and highly volatile liquid. It was first identified in 1890 by a chemist named Ludwig Mond. It is employed industrially in the Mond process for nickel purification. Impure nickel is exposed to carbon monoxide gas under controlled conditions, leading to the formation of nickel tetracarbonyl. Subsequent heating causes the compound to decompose, depositing pure nickel. It is a synthetic creation, produced in laboratories and refineries, and does not occur naturally on Earth. According to this researcher, it is the only compound that explains the nickel emission profile observed from oumuamua, including its temperature sensitivity, its intermittent behavior, and the lack of iron. But if nickel tetracarbonyl is present on a comet purportedly billions of years old, formed in a primordial planetary disk, how did it originate? Natural processes do not yield nickel tetracarbonyl. It requires specific conditions: high-pressure carbon monoxide interacting with metallic nickel. Furthermore, even if such conditions existed in the early solar system, the compound is inherently unstable and would decompose. It would not survive billions of years in interstellar space, unless it is actively being generated. This raises an even more profound question: generated by what? The report then shifts its focus to the dust particles. The dust it sheds is equally anomalous. Measurements of how light reflects off these particles and its polarization provide information about their texture. Every known comet and asteroid exhibits data within a specific range. The data for this object deviates so significantly from expectations that our director insisted we were making errors for almost a week, until we repeated the measurements. The only way to reconcile these figures is if the dust grains are something entirely different, not sand, not ice. Large, exceptionally complex particles. Material that is black and porous, akin to smoke, is not natural dust. It appears to be manufactured. The chemistry is inconsistent with natural processes. The physics is incongruent. It presents a perfectly self-consistent system of anomalies, as if designed to induce self-doubt. Manufactured material. That is the phrase employed. We do have publicly available data regarding the polarization. A paper was published in September analyzing optical observations from multiple telescopes. The degree of polarization for oumuamua was measured at -2.1% at a phase angle of approximately 90 degrees. Negative polarization at this angle is exceedingly rare. It indicates that the light is polarized perpendicular to the scattering plane, a phenomenon observed only with particles possessing highly irregular shapes and complex internal structures. The paper noted this as unusual, but refrained from declaring it impossible. This alleged insider claims that internal discussions progressed further, indicating that the measurements fell so far outside established parameters that instrument error was initially assumed, until repeated observations yielded identical results. If the dust grains are large, intricate, and porous, this suggests a formation mechanism distinct from anything observed in conventional comets. Comets release dust when ice sublimes, dislodging particles from the surface. This ejected dust is typically small, on the micron scale, composed of relatively simple silicate or carbonaceous grains. However, large porous particles point to a different origin. As the report suggests, it resembles smoke. Aerosol particles, finely dispersed material with a substantial surface area to volume ratio. This is the type of dust produced by combustion or industrial processes, or from the breakdown of solid material into an ultra-fine powder, rather than by ice sublimating from a rock. The report further discusses its rotation, or rather the absence thereof. A feature that should not exist has been observed: a faint, diffuse tail pointing directly towards the sun. This is attributed to a massive carbon dioxide jet emanating from the sun-facing side, powerful enough to dislodge heavy water ice grains that sunlight cannot easily displace. Essentially, a violent directional propulsion. However, it is not rotating. Observations spanning days revealed no change in brightness, not even a fraction of a percent. It remains a perfectly flat line. Such a powerful jet from a rotating body would inevitably produce pulsations, flickers, or a discernible rhythm. Instead, we observe absolute, unwavering stillness. The explanation for the tail necessitates a forceful, directed event. The observation of its light, however, indicates a uniformly distributed cloud. These two observations are contradictory. One must be inaccurate. Either the model describing the tail is incorrect, or the cloud itself is not natural. This point, though subtle, is crucial. If oumuamua were rotating and possessed a jet emanating from one side, we would expect periodic variations in its brightness as the jet periodically moved into and out of view, and as different portions of the nucleus reflected sunlight towards us. This is standard behavior for comets, where brightness curves, or light curves, exhibit fluctuations. Oumuamua, however, does not. According to this researcher, its brightness is constant and stable, a dead flat line. This implies one of two possibilities. Either the object is not rotating at all, which is nearly impossible for an object that has traversed space for billions of years, as every collision and gravitational interaction imparts angular momentum, or the brightness remains constant because the outgassing is perfectly symmetrical and isotropic, occurring equally in all directions at all times. However, a symmetrical outgassing pattern cannot account for the forward-pointing tail, which clearly indicates directionality, a jet, and asymmetry. Consequently, we are presented with two irreconcilable observations: a tail that demands a jet and a brightness curve that necessitates symmetry. Both cannot be simultaneously true unless the surrounding cloud of dust and gas is somehow decoupled from its rotation, or unless the object actively regulates its surface activity to maintain a constant brightness regardless of its orientation. Neither of these scenarios is consistent with natural phenomena. Then there is the thermal anomaly. The object is cold. It is absorbing gigawatts of solar energy, sufficient to power a small city. When we calculate the energy budget, there is a substantial surplus. This heat must dissipate somewhere. It should be driving off immense plumes of water vapor. Yet, the water is conspicuously absent. It is analogous to directing a blowtorch at an ice cube and observing that it refuses to melt. The object has evidently devised a method to either dissipate or regulate an enormous thermal load, maintaining its surface temperature at a specific, low level. Energy balance, one of the most fundamental principles in physics, dictates that energy input must equal energy output plus or minus any stored energy. For a comet approaching the sun, the energy input is solar radiation. The energy output comprises thermal radiation and the latent heat of sublimation. As ice transforms into gas, it absorbs energy, which is how comets remain cool. The sublimation process acts as a heat sink. However, if oumuamua is absorbing gigawatts of solar power and not releasing commensurate amounts of water vapor, where is the energy being directed? According to this researcher, the thermal models do not balance. There is a surplus of heat that should be driving activity but is not manifesting in the expected emissions. One potential explanation is a highly reflective surface. If a significant portion of sunlight is reflected rather than absorbed, the energy input would be lower. However, in such a case, the object should appear brighter than it does. Another possibility is that the heat is being conducted into the interior and stored within the bulk mass. This would require exceptionally high thermal conductivity, which is unusual for icy material. Alternatively, the heat could be radiated away at wavelengths we are not detecting, such as infrared or far infrared. Or, and this sounds improbable. The object is actively regulating its surface temperature, a conclusion that the data appears to support. Finally, we must consider its trajectory. This is before even examining the path it took to reach us. Its trajectory is statistically improbable. It follows a perfect low angular momentum orbit, one that guarantees a close passage. Physicists specializing in this field are unequivocal. No known natural process can channel massive objects on such trajectories. It was not merely a random encounter. For all practical purposes, this object was delivered from the void. We have already discussed the alignment with the ecliptic and the timing of planetary encounters, along with their associated probabilities. This adds another layer, low angular momentum. This implies that the orbit is not only aligned with the planets, but also that the object is moving relatively slowly compared to typical interstellar speeds. Most interstellar objects swiftly traverse the solar system at speeds of tens of kilometers per second. Oumuamua, for instance, was traveling at 26 kilometers per second relative to the Sun. Oumuamua, on the other hand, is moving at approximately 60 kilometers per second in interstellar space. However, when accounting for the Sun's gravitational influence, its speed during its close approach is reduced, becoming more manageable, almost as if it were intended to linger. The report concludes with a unifying statement. The speaker asserts that these are not isolated issues, but rather symptoms of a single underlying problem. A jet powerful enough to create the observed tail should cause the object to flicker. It does not. An object of such immense mass should be inert. It is not. The sun's heat should be incinerating it. It appears unaffected. Each paradox represents a barrier. We stand here, fixated on these barriers, refusing to perceive the shape of the room. This is not a failure of our models. It is a glimpse into the underlying mechanisms that govern them. And these mechanisms are flawed. This phrase, a glimpse of the machinery running underneath, is haunting because it suggests that the anomalies are not errors, but intended features, meaning the object is not malfunctioning, but operating according to principles we do not yet comprehend. The researcher then proposes an explanation, one that sounds like science fiction, but which, according to them, represents the only physical framework that renders the data coherent. Chapter 4. The Chemical Nightmare. Let us examine what is actually emanating from this object. Because the chemistry is not merely unusual, according to the leaked report, it is impossible. The nickel anomaly begins with temperature. When the Very Large Telescope's UV spectrograph was directed at Oumuamua between August and September, it detected emission lines corresponding to nickel atoms. Not nickel compounds, but pure atomic nickel glowing within the spectrum, present at every observation epoch. Herein lies the problem. Nickel is a refractory metal with a melting point of 1,455 degrees Celsius and a boiling point of 2,913 degrees Celsius. At the distance at which Oumuamua was orbiting, between 3.1 and 2.1 astronomical units from the Sun, the surface temperatures would have ranged between -100 and -50 degrees Celsius, far below the threshold at which solid nickel could sublimate into atomic vapor. Yet, it is observed streaming off in measurable quantities. The official explanation provided in the published paper is cautious. Quoting the researchers, "The presence of nickel and iron atoms in a cometary coma is extremely puzzling. At the distances where comets are observed, the temperature is far too low to vaporize silicate, sulfide, and metallic grains containing nickel and iron atoms. They suggest a parent molecule, some organic compound containing nickel that decomposes upon exposure to sunlight, releasing nickel atoms. However, they do not identify this molecule, as nickel does not readily form many volatile compounds in nature. It is chemically stable and tends to remain in a solid state." The alleged insider goes further, naming the molecule as nickel tetracarbonyl and explaining why this is profoundly concerning. Nickel tetracarbonyl is classified by chemists as an organometallic compound, consisting of one nickel atom bonded to 4 carbon monoxide groups. It is a liquid at room temperature, highly volatile, boiling at 43 degrees Celsius, and crucially, it is photosensitive. Exposure to ultraviolet light, such as that emitted abundantly by the sun, causes it to break down. The carbon monoxide groups detach, leaving behind pure nickel atoms. This scenario would perfectly explain the observations. Nickel tetracarbonyl on the surface, warmed slightly by sunlight, begins to sublimate. The vapor drifts into space. Ultraviolet photons strike it, causing the molecule to decompose. Atomic nickel then appears in the spectrum. Because the breakdown is driven by light rather than solely by heat, the nickel production would be extremely sensitive to solar illumination. Even a minor change in distance or a slight shift in angle would dramatically alter the rate of production. This aligns with the VLT data, which indicates that the nickel production rate increases sharply as Oumuamua approaches the Sun to the 9th power, according to the measurements, a steep, sharp dependence, precisely as expected from a photodissociation process. Therefore, the chemistry appears to fit. However, here lies the critical issue. Nickel tetracarbonyl does not occur naturally. It is a synthetic compound, produced industrially using the Mond process. This involves exposing metallic nickel to carbon monoxide gas under high pressure and moderate temperature, leading to the formation of nickel tetracarbonyl. Subsequent heating in a different chamber causes the compound to break down, yielding purified nickel. This refining technique was patented in 1890. How then could a synthetic industrial chemical be present on an interstellar comet? One possibility is that the conditions necessary for the formation of nickel tetracarbonyl exist in space. Protoplanetary disks are rich in carbon monoxide. If metallic nickel grains are also present, and if the pressure and temperature are appropriate, the compound might form naturally. While not impossible, this is improbable. Furthermore, even if it were to form, nickel tetracarbonyl is unstable and decomposes over time, particularly when exposed to radiation. An object traveling through interstellar space for billions of years, bombarded by cosmic rays, should not possess intact nickel tetracarbonyl on its surface, unless it is being actively and continuously generated by some internal process. This is the assertion made by the insider. Oumuamua is not carrying ancient nickel tetracarbonyl from its formation. It is generating it as a byproduct of whatever is occurring internally. Then there is the matter of iron, or rather, its absence. In typical comets, nickel and iron are found together, present in similar ratios to their cosmic abundance, roughly 1 nickel atom for every 20 iron atoms, which is consistent with material formed in a protoplanetary disk around a star. Oumuamua exhibits extreme nickel dominance. Iron only became detectable in the spectrum when the object was closer than 2.64 astronomical units. Even then, the nickel-to-iron ratio remains significantly higher than normal by an order of magnitude. The question arises, if both metals are present in the comet's composition, why does nickel sublimate freely while iron remains locked within? The insider's explanation links back to nickel tetracarbonyl. Iron does not form a comparable volatile compound. While iron pentacarbonyl exists, it is less stable and less likely to form under the same conditions. If the outgassing process preferentially produces nickel tetracarbonyl, nickel would be observed without iron. The chemistry is selective. However, this again implies an active process, not merely the sublimation of ice carrying metallic grains. It suggests something chemically sophisticated. Now, let us address the dust, as the polarization data is where the situation becomes truly perplexing. When light scatters off dust particles, the angle of polarization is contingent upon the size, shape, and composition of these particles. Astronomers utilize this as a diagnostic tool. By measuring the polarization and comparing it to theoretical models, they can infer the nature of the dust. Every comet and asteroid ever studied falls within a predictable range. Silicate dust, ice grains, and carbonaceous particles all produce similar polarization signatures, with minor variations within established bounds. Oumuamua's data, however, is unprecedented. According to publicly available information, the polarization at a 90-degree phase angle is negative 2.1%. Negative polarization at this geometry is exceedingly rare. It typically necessitates particles with exceptionally irregular shapes or intricate internal structures. The leaked report describes the reaction upon the initial receipt of this data. Our director insisted we were messing up for the best part of a week until we repeated the result. The instruments were meticulously checked, recalibrated, and reobserved, yielding the same outcome. The only explanation for these figures, according to the report, is that the dust grains are fundamentally different. They are not natural dust, not the type of particles formed when ice sublimates and carries rocky material from a comet's surface. The report states, large, incredibly complex particles, black and porous as smoke. Consider the implications. Typical cometary dust is microscopic, on the micron scale, consisting of simple grains. However, large, complex particles suggest aggregation, fluffy structures with extensive internal void spaces, a high surface area, and low density, akin to soot or aerosols. This is the kind of dust generated by combustion or chemical vapor deposition, processes that build particles atom by atom, layer by layer, creating intricate structures, unlike the natural processes occurring on a frozen rock. Furthermore, it is black. Most cometary dust is relatively bright, reflecting a significant amount of sunlight, which is why comets are visible. Black dust, conversely, absorbs light. It possesses excellent thermal efficiency and heats up remarkably fast. If the particulate matter surrounding 3I Atlas were dark and porous, it would readily absorb solar radiation, leading to a significant temperature increase and subsequent infrared emission. This brings us back to the thermal quandary. Where is all this captured energy dissipating? The internal analysis frames the peculiar chemical characteristics as part of a larger, perplexing pattern. The assessment states, in essence, that the chemistry is incongruous and the physics is aberrant. It describes a system that is internally consistent in its deviation from established norms, as if its very existence is designed to undermine our confidence. This concept of internal consistency is paramount. While each individual anomaly might be dismissed as an isolated oddity, their collective presence forms a cohesive, albeit unnatural, narrative. It is akin to examining a complex mechanism where every single component deviates slightly from its specifications, yet the entire apparatus functions. This leads one to question whether the original specifications are flawed or if the device adheres to an entirely different set of operational standards. It is important to emphasize the current prevailing scientific consensus, supported by the majority of astronomers, which posits that 3I Atlas is indeed a comet. While it exhibits uncommon traits and pushes the boundaries of our observational understanding, it is still considered a natural phenomenon, explicable within the established paradigms of planetary science. NASA has formally articulated this stance. Tom Statler, NASA's principal scientist for small bodies in the solar system, informed reporters that the object resembles a comet. It exhibits comet-like behaviors. In nearly every aspect, it strongly mirrors the comets we are familiar with. His observation is indeed valid. 3I Atlas possesses a coma and a tail, and it is actively outgassing as it approaches the Sun, all of which are characteristic cometary behaviors. However, the intricacies, specifically its chemical composition, the nature of its dust, and its thermal equilibrium, are the subjects of ongoing investigation and present significant challenges. The document, originating from internal sources, does not assert definitive conclusions. It refrains from proclaiming the object as unequivocally alien or artificially constructed. Instead, its assertion is more straightforward and, in some respects, more unsettling. The analysis indicates a failure to adequately explain the observations, with ongoing efforts to gather more data. The term employed was failed. If this information leak is authentic and accurately reflects discussions within the European Space Agency's working group, then it signifies that scientists examining this data are privately acknowledging their inability to provide definitive answers. This then begs the question: if conventional explanations prove insufficient, what alternative frameworks can be considered? It is at this juncture that the internal document ventures into theoretical physics or, depending on one's perspective, science fiction. Chapter 5 delves into the perplexing absence of observable rotation. Every celestial object in the cosmos is in a state of rotation. This is an inevitable consequence of cosmic events, such as collisions imparting angular momentum or gravitational interactions adding spin. Even the most subtle cosmic interaction, occurring billions of years ago, would leave an object in a state of perpetual rotation. Therefore, rotation is the default condition. Consequently, when astronomers observe a new comet or asteroid, one of their initial investigative steps is to determine its rotation period, essentially, how rapidly it is spinning. This is achieved by monitoring its brightness over time. As the object rotates, different surface features, whether dark or bright areas or irregular shapes, orient themselves towards the observer. This causes fluctuations in brightness, ranging from subtle shifts to dramatic variations, but variations nonetheless. This phenomenon is referred to as a light curve. Plotting brightness against time yields a periodic wave pattern, where the period indicates the rotation rate and the amplitude reflects the degree of surface irregularity. This is one of the most fundamental measurements in observational astronomy. However, 3I Atlas deviates from this norm. According to the leaked document, the object has been subjected to continuous monitoring. The Hubble Space Telescope, the James Webb Space Telescope, and numerous ground-based observatories have tracked it nightly, yet its brightness has remained remarkably constant. The report explicitly states, "We've stared at it for years, and it's a dead flat line. Absolutely unwavering. No variation, no flicker, no discernible periodic signal." This constancy is not merely unusual, it is fundamentally incorrect. Even a perfectly spherical celestial body, if possessing any surface irregularities, such as variations in albedo, reflectivity, or distinct patches of differing brightness, would exhibit fluctuations in luminosity as it rotates. Moreover, comets are inherently asymmetrical. They are characterized by irregular shapes, bumps, and craters. Outgassing phenomena can create bright spots, while the accumulation of dust can lead to darker regions. Rotation is expected to generate a predictable rhythmic pattern, yet 3I Atlas remains devoid of any such variation. There is, admittedly, one scenario where rotational patterns might not be immediately apparent: if the object rotates exceptionally slowly, with a period spanning weeks or months. In such cases, detecting a complete rotational cycle within limited observation windows might be challenging. However, even under these circumstances, One would anticipate observing gradual shifts in brightness as the object slowly turns, a discernible drift or trend. The document characterizes the brightness of 3I Atlas as unwavering, stable, and fixed. This implies one of two possibilities. Either the object is not rotating at all, a scenario that is physically implausible for an object of its kind, or it is rotating, but its brightness is somehow unaffected by this rotation, a situation that demands a specific explanation. The situation becomes more complex when considering that both the Hubble and Webb telescopes observed a distinct feature, a forward-facing tail, or plume, of material directed towards the sun. The conventional scientific explanation for such a phenomenon is a jet of gas and dust expelled from the sunward side of the comet, where solar heating is most intense. Jets are commonplace on comets, with sublimating ice creating pressure that forces gas through cracks or vents, carrying dust along with it to form a directional plume. However, jets are inherently asymmetric. They originate from a specific location and project in a particular direction. If the object is rotating, the jet would rotate along with it, periodically pointing towards the observer, then away or sideways. This would result in variations in the amount of reflected sunlight, leading to observable pulses, flickers, or changes in brightness synchronized with the object's rotation period. 3I Atlas exhibits a feature resembling a jet, yet it lacks any corresponding brightness variation. These two observations are mutually incompatible. The internal document articulates this contradiction starkly. A jet powerful enough to create the tail should cause the object to flicker. It does not. The explanation for the tail necessitates a forceful, directed event, while the observation of its light demands a uniform, passive phenomenon. Let us dissect this discrepancy. If the tail is a genuine manifestation of a jet, then this jet should be visibly correlated with periodic changes in brightness. Yet, the brightness remains constant. This suggests either that the tail is not a jet, but something else entirely, or that the brightness is somehow dissociated from the jet's activity. One theoretical possibility is that the outgassing is isotropic, meaning it occurs uniformly in all directions, akin to a sphere slowly evaporating. In this scenario, there would be no distinct jets or asymmetry. This would account for the constant brightness, but fails to explain the presence of the forward-pointing tail. Isotropic outgassing typically produces a symmetrical coma and a tail that is swept back by the solar wind, not a plume directed towards the sun. Another potential explanation is that the cloud of dust surrounding the object is so dense and optically opaque that it effectively masks any brightness variations. The jet might be active, but its emission is concealed within a pervasive fog, with the observed emission representing only the outer, uniform envelope. While this scenario could theoretically reconcile the observations, it would necessitate an exceptionally high rate of dust production. However, spectroscopic data indicates that the coma is relatively tenuous, not optically dense. A third possibility is that the object actively regulates its brightness, somehow maintaining a consistently reflective surface irrespective of its rotation or any jet activity. This notion may sound improbable, but it is the only conceivable scenario that can align both sets of observations without dismissing one as erroneous. The internal assessment suggests this points to a more profound underlying mechanism, proposing that the issue of rotation is not an isolated problem, but rather an integral component of the same systemic anomaly. This anomaly is attributed to the same fundamental process that explains the lack of recoil from outgassing, the generation of synthetic chemistry, and the shedding of manufactured dust. Furthermore, this underlying mechanism, according to the document, is internal rather than externally powered by solar energy or heat. This leads us to the subsequent perplexing observation, the thermal ghost. 3I Atlas is absorbing gigawatts of solar energy, a figure derived from calculable parameters, its cross-sectional area multiplied by the solar flux at its distance. For an object approximately 5 kilometers in diameter situated at about 2 astronomical units from the sun, the absorbed power approaches several gigawatts, enough to power a small city. This absorbed energy must be dissipated. In a typical comet, this energy is utilized to sublimate ice, water, carbon dioxide, and other volatiles. The phase transition from solid to gas is an energy-intensive process, effectively absorbing heat. This is the primary mechanism by which comets maintain their coolness. The sublimation process acts as a heat sink, converting incoming energy into gaseous outflow. However, a critical problem arises. The quantity of energy being absorbed does not correlate with the volume of material being released. The leaked internal document indicates that the thermal models do not achieve balance. It states, "We calculate the energy budget and there's a massive surplus. That heat has to go somewhere. It should be driving off enormous plumes of water vapor, but the water isn't there." The James Webb Space Telescope's analysis of the gas composition revealed a prevalence of carbon dioxide with some carbon monoxide. water vapor is present, but in quantities significantly lower than anticipated. The ratio of carbon dioxide to water is 8:1, an exceptionally high proportion. Most comets are predominantly water-driven, with water being the primary volatile substance that fuels their activity. If 3I Atlas is absorbing gigawatts of energy without releasing a commensurate amount of water, the logical question is, where is this energy going? One possibility is that it is being radiated away. All objects emit thermal radiation, and the hotter they are, the more they radiate. If 3I Atlas possesses a high emissivity and its surface is adept at radiating heat, it could dissipate energy into space without necessitating the sublimation of substantial quantities of ice. However, a significant contradiction emerges. Spectroscopic data suggests that the surface temperature is remarkably cold, far colder than would be expected for an object absorbing such a vast amount of solar energy. The report quotes, "The object is cold. It's akin to pointing a blowtorch at an ice cube and observing that it refuses to melt. Thus, the object absorbs gigawatts of energy, releases minimal water, and remains cold. This excess energy is effectively vanishing. Into what? And where?" The internal document posits that the object has developed a mechanism for regulating its thermal load. It states, "The object has found a way to either dispose of or regulate an enormous thermal load to keep its temperature." The term regulate implies control and a systematic process, rather than passive thermal physics or active management. If the surface temperature is being artificially maintained at a low level, this would require either an exceptionally efficient cooling system or an internal heat sink capable of absorbing and storing or transforming energy without elevating the surface temperature. What natural phenomenon could achieve this, particularly on a comet? The internal analysis concludes that the gigawatts of solar energy are a trivial external variable to a monstrous 3 billion-year-old object with its own power source. It passively radiates solar energy as any inert rock would, because the sun is not integral to its life cycle. Its energy source is internal, an engine generating power from within, independent of solar heating. If this is the case, then the thermal regulation is not an enigma, but a consequence. The object is not reliant on the sun, it is indifferent to it. This raises perhaps the most disconcerting question of all. If 3I Atlas possesses an internal power source, what could it be? Chapter 6 explores the cue ball hypothesis. At this point, the leaked document delves into physics that sounds like science fiction. But according to the researcher cited, it represents the only framework that renders the observed data coherent. The document states, "It is a macroscopic quantum object, a stable, massive particle left over from the first microseconds of the Big Bang, a bubble of a different set of physical laws that has managed to survive, cloaked in a skin of our reality." The theoretical physics designation for this engine is a non-topological soliton. The author asserts this is not merely a theory but the sole, known physical explanation that makes the data internally consistent. A cue ball. Let us examine what this entails. In the universe's nascent moments, immediately following the Big Bang, conditions were extraordinarily extreme, with temperatures and densities far exceeding anything we can currently replicate. Under such energetic conditions, the fundamental forces of nature behaved differently. Particles that are now distinct, such as electrons, quarks, and photons, were unified within a superheated plasma. As the universe expanded and cooled, it underwent phase transitions. Symmetries were broken, forces separated, and matter condensed into the forms we recognize. However, phase transitions do not always occur uniformly. Just as freezing water can create pockets and bubbles, the early universe might have generated localized defects. These were regions where the phase transition did not complete seamlessly, resulting in trapped, stable pockets of the older, unified state. These imperfections are known as cosmic strings, monopoles, domain walls, and cue balls. A cue ball is classified as a non-topological soliton, a term laden with jargon. To clarify, a soliton is a self-sustaining wave, essentially a lump of energy that maintains its shape due to a delicate balance between dispersive forces attempting to spread it out and nonlinear effects that pull it together. Non-topological signifies that its stability is not derived from the geometry of space, like a knot, but rather from a conserved quantity, a charge. The Q in cue ball refers to this charge. Within certain theoretical models, particularly supersymmetric extensions of the standard model, cue balls can form. They are composed of scalar fields, which are fields possessing zero spin. These fields possess potential energy, and under specific configurations, they can give rise to stable, massive objects, essentially, bubbles where the field value inside differs from that outside. The bubble does not collapse because this particular field configuration is energetically favorable, representing a local minimum in the potential energy landscape. The defining characteristic of a cue ball is that it is its own energy source. The field within the bubble decays extremely slowly, releasing energy over billions of years. This energy manifests as particles, radiation, and heat. The cue ball gradually loses mass, but this process is so protracted that a cue ball formed in the early universe could conceivably persist to the present day. It is important to note that this is speculative physics. Cue balls have never been observed. While they are predicted by certain theories, these theories remain unconfirmed. Most physicists regard them as intriguing hypotheticals, objects that might exist in the universe, but are unlikely to do so. The internal analysis, however, claims that 3I Atlas perfectly aligns with the predicted profile. Let us trace the logical progression. If 3I Atlas is a cue ball, what observable characteristics would we anticipate? Firstly, immense mass concentrated within a small volume. Cue balls are inherently dense due to the concentrated field within. A cue ball measuring 3 kilometers across could plausibly possess the mass of a small moon, estimated at 33 billion tons. This aligns with the minimum mass estimate derived from the absence of non-gravitational acceleration. Secondly, isotropic outgassing. The decay process of the cue ball occurs internally at its core, releasing energy uniformly in all directions. This energy heats the surrounding material, an accumulated mantle of ice and dust, from the inside out. The ice then sublimes symmetrically, eliminating any distinct jets or directional thrust. The outgassing is perfectly balanced, resulting in no net recoil. This explains the perplexing observation of powerful outgassing with no discernible propulsive effect. The internal decay engine generates the gas, which then escapes equally in all directions, satisfying Newton's third law as action and reaction cancel each other out. Thirdly, constant brightness. If the outgassing is isotropic, the surrounding cloud of dust and gas would be spherically symmetric. In such a scenario, the object's appearance would be uniform from every angle, regardless of its rotation. Consequently, the brightness would not fluctuate because there is no asymmetry to rotate into and out of view. Fourthly, exotic chemistry. The decay process of a cue ball does not adhere to conventional thermodynamics. It is a particle physics phenomenon, operating at high energies and capable of producing unusual chemical compounds. The document refers to this as a slow burn reactor, which, despite operating at a constant low temperature, is not a thermal furnace, but rather a quantum decay event. Over billions of years, this process yields byproducts such as complex molecules, metallic carbonyls, and manufactured dust, essentially, the exhaust from an ancient engine. Fifthly, thermal indifference. A cue ball is unaffected by solar radiation. Its internal energy source far surpasses the heat generated by the sun. The surface temperature is regulated not by absorbing and re-radiating solar energy, but by the steady output from its core. The gigawatts of solar energy are described as a trivial external variable. Sixthly, its trajectory. If cue balls are prevalent and constitute a component of dark matter, then the galaxy would be replete with them, not rare or anomalous. 3I Atlas would not be debris ejected from a distant star, but an intrinsic component of the cosmic population, a relic from the Big Bang. This would explain the rapid discovery of such a massive object. We are not observing ejected planetary material, but, potentially, dark matter itself. The internal document presents this as a revelation, stating, the cue ball is the mass. Its engine is its own decay. The lack of recoil is no longer a paradox. It's a defining feature. The outgassing isn't a jet. It is an isotropic ablation, a perfectly spherically symmetric outflow of matter. As the core's energy boils its mantle from the inside out, there is no net thrust. It moves without consequence because the event is happening inside a perfectly balanced system. And it continues. This is not a matter of belief. This is the only known physics that makes the data coherent. Once you look at it, the entire system of wrongness snaps into a logical, horrifying picture. The term horrifying is used, not intriguing or surprising. The reason for this designation is profound. If 3I Atlas is a cue ball, then dark matter is not merely invisible, inert matter scattered throughout space. It is active, massive, and ubiquitous. The galaxy would not be sparsely populated with a few interstellar rocks, but teeming with ancient, massive objects, each a relic from the Big Bang, each slowly decaying, each capable of entering a solar system and initiating. What? Either nothing, or something far more sinister. However, and crucially, the cue ball hypothesis is testable. The document concludes by presenting specific, falsifiable predictions. Screenshot this, it urges. First prediction, activity independent of solar distance. The behavior of a conventional comet is fundamentally driven by solar heating. As it moves away from the sun, its activity diminishes, outgassing slows, and brightness fades. This is a universal principle observed in all comets studied to date. However, if 3I Atlas possesses an internal engine, its activity will not conform to this pattern. As it recedes into the outer solar system, beyond 3 astronomical units, and then beyond 4, its brightness and mass loss rate are predicted to remain impossibly high. It will defy the thermodynamic expectations for a passive cooling body. This is a testable assertion. We can observe this phenomenon. When the object reappears in December, after passing behind the sun, we will have several months to observe it as it moves outward. If it remains bright, and if the outgassing continues unabated, this will serve as definitive evidence. Comets do not behave in this manner. Second prediction, high-energy emissions. The decay of a cue ball is a particle physics event, estimated to release 73 megawatts of energy according to the document. This energy does not simply vanish. It produces particles, including high-energy particles such as gamma rays and X-rays, creating a non-thermal, high-energy signature that should be detectable. The text advises, point a gamma-ray telescope at it. If you detect a signal that is not attributable to solar-wind interaction, you're not seeing a comet. You're hearing the heartbeat of an object that doesn't follow the rules of physics. This, too, is testable. Gamma-ray observatories are operational. The Fermi Gamma-ray Space Telescope, for instance, could potentially detect such emissions. If a high-energy source is identified at the location of 3I Atlas, we can confirm its presence. No comet emits gamma rays through internal processes. Only extreme astrophysical objects such as pulsars, black holes, supernova remnants, or, if this hypothesis is correct, cue balls, do so. Let me be unequivocally clear. This is not within the realm of mainstream science. Cue balls are theoretical and speculative. The majority of astrophysicists would likely dismiss this hypothesis outright. It is an exotic proposition, requiring the acceptance that dark matter exists in a form never before detected, that the early universe produced stable, macroscopic quantum objects, and that one such object is currently traversing our solar system. The more parsimonious explanation posits that 3I Atlas is simply an unusual comet, exhibiting peculiar chemistry, strange dust composition, perhaps a binary nucleus, or some internal structure yet to be fully understood, but ultimately a natural object, explainable within conventional planetary science. That is the stance most scientists adhere to, and their perspective could indeed be accurate. However, if the purportedly leaked correspondence is authentic, if a European Space Agency working group is genuinely grappling with reconciling the observed data, then the concept of a CQ ball is being quietly debated behind closed doors. It's not presented as the definitive answer, but rather as the sole viable alternative that doesn't necessitate disregarding a significant portion of the empirical evidence. Furthermore, should the predictions prove true, should 3I Atlas remain luminous as it recedes, and should gamma rays be detected, the tenor of the discussion will undoubtedly shift with considerable alacrity. Chapter 7. The Concealed Maneuver Window. In 26 days from the present, 3I Atlas will perform an action that ought to instill widespread unease. It will vanish from sight. This disappearance will not be literal. The celestial body will persist, continuing its journey along its established trajectory. Yet, from our vantage point on Earth, it will become imperceptible, obscured by the sun, utterly swallowed by the intense radiance of our own star. This event is slated to occur on October 24th. At this juncture, the object will attain solar conjunction, forming a precise alignment where Earth, the Sun, and 3I Atlas lie on a straight line with the Sun positioned at the center. From this point until the early days of December, we will be rendered incapable of observing it, tracking its progress, or determining its location, luminosity, or spectral characteristics. For a period of nearly 6 weeks, the object will effectively cease to exist from our observable universe. And on October 29th, precisely in the midst of this observational blackout, 3I Atlas will reach its perihelion, its closest point of approach to the Sun, a distance of 1 4/10 astronomical units, situated just within the orbital path of Mars. This is the very moment when solar heating is at its peak, when a typical comet would exhibit its greatest activity, and when its outgassing would reach its zenith, yet we will be unable to witness any of it. This particular timing has not escaped notice. Loeb addressed it explicitly in his article published on October 3rd. His statement read, in part, at its perihelion on October 29, 2025, when it reaches 1 3500 astronomical units from the Sun, 3I Atlas will be completely hidden from Earth by the Sun. If we posit that this obscuration occurs within a solar elongation of 30 degrees, then it is a straightforward calculation to determine the probability of this alignment with the Sun and Earth as approximately 7%. 7%. This is not an impossible figure, nor is it mere random chance. It represents a 1 in 14 likelihood, and this is where the situation becomes rather disconcerting. If 3I Atlas were a spacecraft, if it possessed propulsion capabilities, if it were capable of executing maneuvers, perihelion would represent the optimal moment to do so. specifically to execute what is termed a reverse Orth maneuver. Allow me to elucidate. The Orth effect is a fundamental principle in the study of orbital mechanics. When a rocket engine is engaged, the resulting alteration in kinetic energy is contingent not solely on the magnitude of the thrust, but also on the object's current velocity. Engaging the engine while moving at a high velocity yields a more substantial return on investment. The gain in kinetic energy is amplified. Spacecraft routinely exploit this phenomenon. When the objective is to break free from the gravitational pull of a planet or a star, thrust is applied at periapsis, the point of closest approach, where the orbital velocity is at its maximum. This constitutes a standard Orth maneuver, maximizing efficiency. A reverse Orth maneuver is its inverse. An object is traveling at high speed on a hyperbolic trajectory, heading out of the solar system, but its intent is to remain within it. It aims to become gravitationally bound. Consequently, engines are fired at perihelion, when velocity is greatest, to decelerate. The reduction in velocity is most effectively achieved at this point. Energy is dissipated, and the trajectory transitions from hyperbolic to elliptical. Rather than escaping, the object achieves capture. If 3I Atlas were intended to remain within the solar system, October 29th would have been the opportune moment to initiate braking, and this action would have occurred concealed behind the sun, invisible and unobservable from Earth. Loeb articulates this meticulously. He is not asserting that this will transpire. Rather, he is highlighting the advantageous geometry of the situation. Quoting from his article, "This could be intentional, designed to evade detailed observations from Earth-based telescopes when the object is at its brightest, or when devices are dispatched earthward from that concealed vantage point. The most advantageous juncture for a reverse solar Orth maneuver, aimed at achieving solar capture, is at perihelion. It is precisely this optimal breaking point for 3I Atlas that is obscured from our view by the sun." The term devices, as he employs it, refers to small probes released from the primary object, leveraging the retrograde orbit and close planetary encounters to reach Mars, Venus, or Jupiter with minimal fuel expenditure. The calculations for this scenario are readily available. In Loeb's July publication, co-authored with Adam Hibbert and Adam CRA, they meticulously detailed the delta-v requirements. Delta-v signifies the alteration in velocity necessary to reach a target. For 3I Atlas to dispatch a probe to Mars in early October, the requisite delta-v is less than 5 kilometers per second. This is comparable to the delta-v needed for an intercontinental ballistic missile, achievable through chemical propulsion. Venus presents a similar proposition, requiring less than 5 kilometers per second until July. Jupiter also falls within this range, demanding less than 5 kilometers per second through November. Earth, however, necessitates a greater delta-v, consistently exceeding 5 kilometers per second, indicating a higher energy cost. This might explain, from the perspective of a reconnaissance mission designer, why Earth is omitted from the initial itinerary. The strategy would be to visit other planets first, gather data, and then ascertain if Earth warrants the fuel expenditure. Again, this remains a hypothetical construct. Loeb is not definitively stating that this is occurring. He is positing the possibility, given that the trajectory and timing permit such actions. However, the crucial element is that we will not possess definitive knowledge until December. When 3I Atlas reemerges from behind the sun in early December, it will appear in the pre-dawn sky, positioned low on the eastern horizon, faint yet observable. The immediate action of astronomers will be to meticulously measure its position, calculate its trajectory, and ascertain if any changes have transpired. If its orbit remains identical to the predicted path, if the object is precisely where it should be based on a purely gravitational interaction, then nothing untoward has occurred. It has successfully navigated perihelion, undergone outgassing, and continued on its trajectory. It would be classified as an unusual but natural comet. Conversely, if the orbit exhibits any deviation, even a minute one, then an event of significance must have transpired behind the sun. Either the object executed a maneuver, or it fragmented, or it underwent some other phenomenon that altered its trajectory. Such an occurrence would be profoundly consequential. Loeb has identified a specific temporal window for potential detection, November 21st to December 5th. Quoting from an earlier blog post, the authors emphasize that their hypothesis is falsifiable. Should 3I Atlas traverse the solar system without executing any unexpected maneuvers, particularly between November 21st and December 5th, 2025, the hypothesis would likely be refuted. 2 weeks. This constitutes the critical observation period. If any maneuvers were undertaken at perihelion, their effects would become discernible as deviations in the trajectory by late November. Astronomers will undoubtedly be vigilant. However, there exists an additional theoretical layer, the precursor probe hypothesis. In September, Loeb published another calculation. This theory posits that if 3i Atlas released a smaller object, a probe, at some point prior to the present, and if that probe were traveling ahead of the primary object by approximately 30 million kilometers, it could have reached Mars this very week, October 3rd, coinciding with the Mars flyby. The mathematical underpinnings of this scenario are sound. A probe does not necessitate substantial dimensions. A few meters across, perhaps 10, the size of a vehicle, would suffice. At such a scale, reflecting sunlight at Martian distances, it would remain invisible to Earth-based telescopes. We would be incapable of detecting it, yet its presence would be plausible. The high-resolution camera aboard the Mars Reconnaissance Orbiter is not exclusively focused on the primary object. According to Loeb's suggestion, it should also be diligently scanning the approach corridor, actively searching for smaller objects, precursors, or scouts. Has NASA implemented such a protocol? We lack this specific information. The imaging plans have not been disclosed with that level of granularity, but the possibility remains extant. And should anything manifest within the data, something diminutive and unanticipated, the prevailing narrative will invariably shift. Currently, the more probable outcome, the one anticipated by the majority of scientific minds, is that nothing extraordinary will occur. 3i Atlas will complete its perihelion passage, continue its outward journey, and gradually recede into obscurity. It will be regarded as a peculiar comet, certainly noteworthy and worthy of extensive study, but ultimately just another interstellar visitor. No maneuvers, no probes, no detectable deviation. This is the baseline expectation, and it is very likely the correct one. Nevertheless, the geometric configuration is unsettling. The temporal sequencing is unsettling. The fact that the most pivotal moment unfolds when we are entirely unable to observe it, that is profoundly unsettling. And when the CQ ball hypothesis is introduced into this equation, the situation intensifies. This is because a CQ ball does not require propulsion, it does not engage in maneuvers. It is inert, yet it possesses immense mass, estimated at 33 billion tons. If such an object were to pass in close proximity to a planet, it would exert a gravitational influence. A planet's orbit could experience a minute, yet measurable, shift over time. Mars presents the primary concern. 3i Atlas is scheduled to pass within 29 million kilometers today. This is a close approach, not a collision course, but sufficiently proximate for gravitational interactions to become significant. If the object indeed possesses the colossal mass indicated by estimates, Mars should register a subtle gravitational tug. Its orbital elements, the precise parameters defining its path around the Sun, could shift by a discernible amount. Astronomers meticulously track Mars on a continuous basis. Its positional data is known with exceptional accuracy. Should 3i Atlas impart even a minor gravitational perturbation, it will be detected, not instantaneously, but progressively over weeks and months as Mars continues its orbital journey. The deviation will accumulate. This represents another critical test, another avenue through which to either confirm or refute the mass estimations. The results of this assessment are anticipated within the ensuing few months. Thus, we await the unfolding events. October will pass, the object will conceal itself, November will arrive, observations will recommence, and by December, clarity will emerge. Did it maneuver? Did its trajectory change? Is its mass as substantial as indicated? The answers are forthcoming, irrespective of our readiness to receive them. Chapter 8. The decoy scenario. Within the overarching theory lies a sub-theory, a layer of speculation built upon speculation, and it is arguably the most disquieting one yet. What if 3i Atlas serves as a deliberate diversion? This notion originated with Omar Dippy, an associate of Avi Loeb. He proposed that an advanced civilization might employ a celestial object that appears to be a naturally occurring interstellar comet as a decoy, something exceptionally bright, conspicuously visible, something designed to capture the attention of telescopes and the public alike, while the genuine operation unfolds elsewhere. Loeb elaborated on this concept in a blog post published in August. He stated, "My collaborator, Omar Dippy, suggested that extraterrestrials might utilize a naturally appearing interstellar comet as a diversionary tactic, drawing our attention while they conduct another operation at a different location in proximity to Earth. From this perspective, it would be pertinent to investigate whether there has been an observed increase in the activity of unidentified anomalous phenomena within Earth's atmosphere in the period following 3i Atlas's closest approach to the Sun on October 31st, 2025. An amplified presence of UAP activity coinciding with 3i Atlas's perihelion is a verifiable hypothesis, and efforts are underway to test it. The Galileo Project, an initiative spearheaded by Loeb, is an astronomical research program dedicated to the search for evidence of extraterrestrial technology. Its methodology bypasses the search for radio signals or distant exoplanets, focusing instead on Earth's immediate vicinity. The project employs telescopes and sensors to continuously monitor the sky for anomalous objects. The project comprises 3 observatories, one situated at Harvard College Observatory in Massachusetts, another in Pennsylvania, and a third in Nevada. Each facility is outfitted with advanced cameras, infrared sensors, radar systems, and audio detectors. These observatories conduct continuous scans of the entire celestial sphere, meticulously recording every moving object overhead. The system utilizes artificial intelligence to categorize these objects, distinguishing between mundane entities like birds, aircraft, satellites, drones, and meteors. The vast majority of these are readily identifiable and explicable. However, on occasion, an object emerges that defies conventional classification, perhaps moving at an anomalous speed or altering its direction in a manner uncharacteristic of conventional aircraft. Such instances are flagged, thoroughly analyzed, and investigated. The Galileo project has been operational since late 2022 and has amassed data on approximately 500,000 aerial objects. While the overwhelming majority are identified and accounted for, leaving no trace of unusual activity, the system remains perpetually vigilant. According to Loeb, it will be operating with heightened intensity throughout October and November. He stated, "Fortunately, the Galileo project will be actively monitoring the skies under my direction, utilizing its 3 observatories located in Massachusetts, Pennsylvania, and Nevada during this critical period. Therefore, if there is an escalation in UAP activity, if unusual phenomena begin to appear in Earth's atmosphere while 3I Atlas is concealed behind the Sun, the Galileo project is ideally positioned to detect it. And if a correlation emerges, if the timing aligns, that would indeed be a significant finding." Now, let us be unequivocally clear about the implications of this statement. Loeb is not forecasting the imminent arrival of alien spacecraft, nor is he definitively asserting that 3I Atlas is a decoy. Rather, he is proposing that if it were indeed a decoy, we should anticipate the detection of secondary activity, and his team is strategically positioned to undertake this observation. The decoy hypothesis is predicated on several fundamental assumptions. Firstly, that 3I Atlas is either of artificial origin or under intelligent control. Secondly, that its purpose is not direct contact, but rather reconnaissance. Thirdly, that the entity responsible for its dispatch or utilization desires to keep humanity preoccupied, focusing its attention on the prominent, conspicuous object while smaller, more covert operations are executed closer to home. Why would an advanced civilization adopt such a strategy? One compelling rationale is the principle of informational asymmetry. When assessing a species that is potentially hostile or unpredictable, direct self-disclosure would be imprudent. Instead, data acquisition would be conducted discreetly, employing small, low observability probes, while simultaneously ensuring the target's attention is diverted elsewhere. 3I Atlas is unequivocally conspicuous. It is bright, visually striking, and exceptionally unusual. Every major terrestrial and orbital telescope has directed its gaze toward it. Scientific papers are being authored, researchers are engaged in fervent debate, and the media is covering it as a significant spectacle. And while humanity's collective gaze is fixed upon the comet, the question arises, what activities are transpiring here on the ground, within our atmosphere, or in Earth's orbital vicinity? Are there smaller, silent objects engaged in activities that are eluding our notice? The data generated by the Galileo project will provide answers, or at the very least, indicate whether there is an observable uptick, a statistical anomaly, an increased number of unexplained objects beyond the norm, concentrated around late October and early November. If such a pattern emerges, it would not constitute definitive proof of the decoy hypothesis. Correlation, as is well known, does not equate to causation. However, it would be exceedingly difficult to disregard such a confluence of events. There exists another perspective, the stealth hybrid spacecraft theory, put forth by Gabor, a dedicated reader of Loeb's work. This concept suggests that an advanced civilization might not construct spacecraft entirely from scratch. Instead, they might repurpose natural materials, such as asteroids or comets, terraform them internally, hollow them out, integrate machinery within, and utilize the natural exterior as a form of camouflage. Loeb quoted Gabor in his blog post, stating, "Humanity is already planning asteroid mining missions, and for a more advanced civilization, this could represent a remarkably straightforward methodology. The hull of an asteroid provides exceptional natural shielding. The object itself offers inherent stealth. As long as there are no active emissions or artificial reflective surfaces, it would appear externally as nothing more than a natural asteroid. This effectively resolves a significant challenge. If one intends to dispatch an object to another star system, robust shielding is imperative. Interstellar space is fraught with hazards, including cosmic rays, high-energy particles, and micrometeorites. Constructing substantial protective walls is an expensive and heavy undertaking. However, by commencing with a natural celestial body, the shielding is intrinsically present. One need only excavate the interior, install the necessary systems, and initiate the journey. From an external perspective, it would resemble a comet, exhibiting outgassing and a coma, behaving in a conventional manner, while internally housing sophisticated machinery, instrumentation, power sources, and perhaps even dormant crew members awaiting activation. This is not a novel speculation. The concept has been a staple of science fiction for decades. Arthur C. Clarke's Rendezvous with Rama features a colossal cylindrical spacecraft disguised as an asteroid. Greg Bear's Forge of God depicts self-replicating machines concealed within comets. The underlying concept is familiar, yet it is also remarkably practical. When undertaking journeys across interstellar distances, spanning millennia in transit, the utilization of natural materials becomes a logical and efficient choice, while simultaneously rendering detection more challenging, as astronomers are predisposed to classify rocky bodies as natural. 3I Atlas has not exhibited any overtly artificial characteristics. There have been no detectable radio signals, no discernible course corrections, and no artificial illumination. It simply does not align perfectly with the available data. The chemical composition appears anomalous, the physics are questionable, and the trajectory raises suspicions, yet none of these factors constitute definitive proof. This ambiguity is the inherent brilliance of a stealth hybrid design. It remains deniable and equivocal. Proving its artificial nature would necessitate an extremely close approach, perhaps even direct interaction. By the time a mission could be launched to intercept it, the object would likely have already departed. Consequently, we are left with a series of profound questions. Will the Galileo project detect anything unusual in the coming weeks? Will the number of reported UAP sightings increase? Will there be objects that defy conventional explanation? And if so, will any observers draw a connection between these phenomena and 3I Atlas? Or will October and November pass uneventfully, with no anomalies, no surge in activity, merely a comet disappearing behind the sun and reappearing on the other side? Strange, undoubtedly, but ultimately natural. The data will ultimately provide an answer, one way or the other. We simply must endure a few more weeks of anticipation. Chapter 9. The Silence Protocol. The scientific community is experiencing a significant division regarding this particular celestial object. This divergence is not manifesting in overt public pronouncements or official statements, but rather within the more circumscribed realms of private communication, email exchanges, informal hallway discussions at conferences, and late-night laboratory conversations. Two distinct factions have emerged, and the chasm separating them is progressively widening. One group maintains that 3I Atlas is, in fact, a comet. They acknowledge its unusual characteristics and its capacity to push observational boundaries, but they firmly assert that it remains within the established parameters of natural astronomical phenomena. They propose that its anomalous chemistry can be explained by the presence of exotic parent molecules that have yet to be identified. Furthermore, they suggest that the mass estimates might be inaccurate, and that more precise data will eventually resolve the discrepancies. Their approach emphasizes patience and rigorous scientific methodology to unravel the anomalies. The opposing faction exhibits a greater degree of uncertainty. They analyze the identical set of data and perform the same calculations, yet they arrive at conclusions that do not align with conventional understanding. These discrepancies are not confined to the periphery of the data, they reside at its very core. The established laws of physics appear to be insufficient to explain the observations unless one accepts premises that are seemingly impossible, such as extreme density, internal energy sources, or synthetic chemical processes. The purportedly leaked 4chan communication eloquently encapsulates this internal conflict. It states, "The official stance is that 3I Atlas is an exceptionally active, yet otherwise natural, comet. This position is no longer sustainable, and the pervasive silence from leadership regarding the cognitive dissonance this necessitates is becoming a significant professional concern for an increasing number of us." The term cognitive dissonance is particularly potent. It denotes the simultaneous holding of two conflicting beliefs. In this context, it refers to the intellectual struggle of accepting the accuracy of the empirical data while simultaneously adhering to the belief that the object is natural. The paradox lies in the fact that if the data is deemed correct, the object's natural classification becomes untenable. Conversely, if its natural origin is accepted as fact, then the collected data must be erroneous. However, the data has undergone repeated scrutiny by multiple independent research teams utilizing diverse instrumentation and methodologies, and the results consistently reaffirm the initial findings. This leaves researchers unable to reconcile these conflicting conclusions in a precarious position. According to the aforementioned communication, they are being implicitly discouraged from exploring alternative explanations. While not explicitly forbidden or censored, the prevailing professional incentives steer towards conventional interpretations. Scientific papers proposing unconventional hypotheses are subjected to more rigorous peer review, and grant applications that incorporate terms such as artificial or non-natural are met with considerable skepticism. Pursuing such avenues can potentially impede the progress of one's career. This phenomenon is not unique to the three-eye atlas situation. It represents a broader systemic issue within the scientific community. There exists a pervasive pressure to remain within established theoretical frameworks, to avoid disrupting the prevailing consensus, and to exercise caution in making extraordinary claims. While this conservative approach is generally beneficial, fostering accuracy and preventing unsubstantiated speculation from overshadowing sound research, it can, on occasion, create significant blind spots. These are instances where empirical evidence points in one direction, while the collective scientific community remains fixated on another. Jason Wright, an astronomer at Penn State University, has been notably vocal in expressing these concerns. He has critiqued Avi Loeb's approach, not only concerning three-eye atlas, but also regarding the earlier analysis of oumuamua. Wright contends that Loeb is excessively quick to attribute artificial origins to observed phenomena, and that he tends to dismiss fundamental observational evidence. He argues that while Loeb's claims garner media attention, they often falter under close scientific scrutiny. Wright articulated his perspective in a blog post. Avi has cultivated a reputation for proposing and outright asserting that certain phenomena could be alien spacecraft, even in the absence of substantial or objective justification for such claims. It was not long before Avi asserted that three-eye atlas was an alien spacecraft. He proceeds to critique specific claims made by Loeb. For example, the assertion that the observed extended source detected by telescopes is merely a result of image smearing. Wright counters this by pointing out that modern telescopes are equipped with sophisticated tracking and image stacking capabilities designed to compensate for object motion, rendering image smearing an irrelevant concern for professional observatories. If multiple independent observations consistently reveal an extended source, it is indicative of a genuine phenomenon. Three-eye atlas possesses a coma, which by definition classifies it as a comet. However, Loeb's response to such criticisms is considerably more nuanced than Wright's critique might suggest. Loeb is not asserting definitive conclusions. Rather, he is proposing a conceptual framework, a scale ranging from 0 to 10. At 0, an object is unequivocally natural, while at 10, it is definitively artificial. He rates three-eye atlas at a 6 on this scale. The possibility remains unconfirmed, but the evidence is substantial enough to warrant intense scrutiny. The proposed classification system itself is quite innovative, intended to steer the discourse beyond a simple dichotomy. Instead of asking if it's extraterrestrial or not, the focus shifts to the degree of its anomalous nature. How far does it diverge from our expectations, and what level of deviation necessitates a specific response? Lower suggested that this scale be formally adopted by a global organization, specifically the United Nations. In October, a white paper was released, authored by Omri Gershoni, Tenenbaum, and Avi Loeb, titled Advancing Interstellar Science, a global framework for comprehensive study of interstellar objects. It advocates for the establishment of UNCIO, the United Nations Committee on Interstellar Objects. The premise is straightforward. As our detection capabilities advance, particularly with the imminent activation of the Vera C. Rubin Observatory, we anticipate discovering a significantly larger number of interstellar objects, potentially one every few months or even more. Each discovery presents a fleeting window for observation as these objects traverse our solar system with great speed. To effectively study them, a coordinated international effort is required, one that is swift and pre-planned. UNCIO would aim to standardize our responses, establish clear protocols, create a network of observatories with guaranteed observation time, maintain a readiness of rapid response spacecraft, and, crucially, implement the LOE scale as the official categorization system. Objects scoring 4 or higher on this scale would trigger enhanced observation efforts. A score of 6 would mandate notification of the UN Security Council, while a rating of 8 or above would initiate emergency procedures. 3i/2025, TATOS is currently rated at a 6. Should it exhibit unusual maneuvers, the detection of gamma rays, or activity independent of its distance from the Sun, its rating would escalate, leading to a corresponding intensification of the international response. This proposal is ambitious, requiring financial investment, political will, and collaboration among space agencies, none of which are guaranteed. However, the foundational framework is in place, and Representative Anna Paulina Luna, a member of the U.S. Congress, has lent her support, as noted in the white paper. The realization of UNCIO hinges on developments in the coming months. If 3I/2025 TATOS simply recedes into the void, the sense of urgency will diminish, and it will likely be relegated to an intriguing case study, a peculiar comet worthy of a scientific paper, but not a global crisis. Conversely, if the object displays behavior that defies conventional explanation, the dialogue will shift, transforming the idea of international coordination from perceived bureaucratic overreach into an essential undertaking. Another significant factor at play is the degree of transparency, or the lack thereof. The post on 4chan hints at internal discussions that have not been made public, data that remains undisclosed, and frustrations that have not been articulated. If these claims are accurate, and if there is a divergence between private scientific discourse and official pronouncements, this discrepancy will inevitably surface, either through leaks or formal revelations. The scientific method fundamentally relies on openness. Data should be shared, hypotheses rigorously tested in the public domain, and peer review conducted transparently. When these principles are compromised, and information becomes siloed or controlled, trust erodes, and speculation fills the vacuum. We currently find ourselves in an uncertain intermediary phase. Sufficient public data exists to provoke questions, but not enough to provide definitive answers. The crucial observational data, including images from the Mars flyby, gamma-ray spectrum analysis, and trajectory measurements from December, are still pending. Within this observational gap, observers are actively engaged, some with their instruments, others with their theories, and a few, reportedly, with privileged knowledge they are not authorized to share. The next phase of this narrative will not be shaped by conjecture, but by empirical data, by observations, and by measurements that will either validate the conventional explanation or compel us to consider alternative possibilities. We are now on the cusp of crucial developments. The Mars flyby occurred today. The perihelion passage is 3 weeks away, and the emergence from solar conjunction is 2 months hence. By the close of the year, our understanding will be significantly enhanced, perhaps not entirely complete, but certainly more informed. Should the anomalies persist, and if the data continues to resist conventional interpretation, then any imposed silence protocols, regardless of their form, will inevitably falter. Eventually, the barriers we erect around unsettling questions begin to crumble, revealing the underlying reality, whether we are prepared to confront it or not. Chapter 10. What transpires next? The images captured during the Mars flyby are expected within days, possibly within a week. The Mars Reconnaissance Orbiter has successfully transmitted its data back to Earth. Engineers are currently engaged in processing, calibrating, and enhancing these images. Soon, we will have visual evidence of what the high-resolution camera observed during the flyby. If the nucleus is clearly discernible and measures 5 kilometers or more in diameter, the significance of its estimated mass, 33 billion tons, will be amplified. The statistical improbability of encountering an object of such magnitude will become undeniable. This would imply either that interstellar space is far more densely populated than previously understood, or that this object possesses exceptional characteristics that elude our current comprehension. Conversely, if the nucleus is smaller than 1 kilometer, the enigma shifts. A small nucleus generating such substantial outgassing and maintaining such luminosity at this distance presents a different kind of scientific challenge. It suggests extraordinary internal activity, a significant heat source, or some driving mechanism for emissions beyond simple solar radiation. Either scenario raises profound questions, and neither fully resolves them. Spectroscopic analysis from the Mars Express and ExoMars Trace Gas Orbiter missions will introduce another layer of data. These instruments are measuring the composition of gases from a closer vantage point, utilizing instruments specifically designed for atmospheric analysis. The detection of compounds not observable from Earth-based telescopes, or even stranger chemical signatures up close, would be highly significant. Furthermore, continuous brightness monitoring is underway. As 3I/2025 TATOS moves away from Mars and proceeds towards its perihelion, the observation window for Earth-based astronomers narrows. By mid-October, the object will become obscured by the sun's glare. Until then, every night of photometry, every recorded spectrum, and every polarization measurement is critical. Scientific teams globally are diligently collecting and archiving this data, constructing a comprehensive timeline. Upon the object's reemergence in December, this chronological record will become invaluable for comparative analysis. We will compare its behavior leading up to perihelion with its behavior afterward. Will its activity profile align with predictions, or will it deviate? A typical comet adheres to a power law, exhibiting increased brightness and outgassing as the inverse square of its solar distance, or even steeper. As it approaches the sun, Its activity intensifies. As it recedes, it diminishes, a predictable, universal pattern. If 3I/2025, TATOS deviates from this established curve, maintaining high activity as it progresses past 3 astronomical units, and then 4, this would constitute a significant red flag. The cue ball hypothesis, as previously mentioned, hinges on this very point. An internal energy source would remain unaffected by solar distance, operating with consistent output, rendering it a falsifiable and testable prediction. We should have a clearer answer by January or February. The ongoing gamma-ray search represents another crucial avenue of investigation. Observatories such as Fermilab and Integral continuously scan the cosmos for high-energy photons. If 3I/2025, TATOS possesses an internal particle physics process or a decay mechanism that generates high-energy particles, these instruments should detect it. To date, there have been no public reports of gamma-ray emissions from 3I/2025 TATOS. However, this does not preclude ongoing searches. Data analysis requires time, signals can be faint, and background noise levels are considerable. A detection might not be immediately announced, or it could be present within a dataset awaiting discovery. If gamma rays are detected and their origin can be correlated with the comet's position, and if they cannot be attributed to solar-wind interactions or cosmic ray impacts, this would be a game-changer. No natural comet emits gamma rays originating from internal processes. Such emissions are characteristic of astrophysical engines like pulsars, magnetars, supernovae, or potentially exotic forms of matter. The subtle gravitational influence on planetary orbits presents a more protracted, yet equally significant, signal. Mars is tracked with exceptional precision, its orbital path known to within meters. If 3I/2025, TATOS exerted a discernible gravitational pull during its close pass, Mars would exhibit a minute deviation from its predicted trajectory. While the displacement might be only millimeters per day, this cumulative effect over months could become measurable. By early 2026, any real deviation, if present, should be detectable. If this deviation aligns with the predicted perturbation from an object weighing 33 billion tons, it would serve as independent confirmation of its mass, requiring no analysis of outgassing chemistry, only the fundamental force of gravity. The UAP, Unidentified Aerial Phenomena, monitoring through the Galileo Project observatories, is currently active. Data is being collected in real time. Should there be a statistically significant increase in unexplained aerial phenomena coinciding with the perihelion passage, it would be reflected in the observed statistics, a higher number of objects, unusual flight paths, and clustering within a specific time frame. The absence of such a spike would not invalidate the decoy hypothesis. It would merely remove one supporting line of evidence. However, the presence of a spike would be difficult to disregard, particularly if the anomalies are concentrated in late October and early November, subsequently diminishing. Furthermore, December 5 marks the conclusion of Loeb's designated detection window for trajectory alterations. If 3I/2025, TATOS executed a maneuver during its perihelion passage, perhaps a retrograde orbit to remain within the solar system, the resultant deviation should be detectable by this date. Observatories will precisely measure the object's position and calculate its orbit in comparison to pre-event predictions. If the orbit remains unchanged and purely gravitational, it would indicate that no maneuver occurred, and the object is simply departing. However, if the orbit exhibits a deviation that cannot be explained by outgassing or fragmentation, it would signify an event transpired behind the Sun, unobserved by us, and thus demanding an explanation. The Vera C. Rubin Observatory, which commenced operations this year, introduces a final element of intrigue. Its comprehensive sky surveys, deep imaging capabilities, and automated detection systems are specifically designed to identify transient celestial objects, including moving bodies such as asteroids, comets, and interstellar visitors. Current models predict that the Rubin Observatory will detect one interstellar object every few months, or potentially more frequently. Within 1 to 2 years, we anticipate cataloging dozens of such objects, each serving as a data point for comparative analysis. Is 3I/2025 TATOS an anomaly, or is it representative of a common galactic population? If subsequent interstellar objects exhibit similar anomalous characteristics, extreme mass, unusual chemistry, consistent luminosity, then 3I/2025 TATOS would not be an outlier, but rather a harbinger, an initial glimpse into a phenomenon prevalent throughout the galaxy that we are only just beginning to perceive. Conversely, if future interstellar objects are consistently small, conventional comets behaving predictably, then 3I/2025 TATOS would stand as a singular exception, rendering it even more mysterious. The broader context is that we are at a critical juncture. For the first time, We possess the technological means to conduct detailed studies of interstellar visitors, not merely detect their presence. This includes advanced spectroscopy, high-resolution imaging, rapid response missions, and international collaborative efforts. 3i/2025, TATOS serves as a significant test case, pushing the limits of our instruments, models, and fundamental assumptions. In doing so, it is revealing deficiencies in our understanding that are more pronounced than we previously acknowledged. Some of these gaps will undoubtedly be addressed through enhanced data acquisition, refined theoretical frameworks, and the discovery of natural explanations that have yet to be considered. Science possesses an inherent capacity to resolve anomalies, though not always instantaneously. Other gaps, however, may widen, evolving into profound chasms, at which point the discourse will fundamentally shift from "what kind of comet is this?" to "what is this?" We have not yet reached that definitive stage, but we are sufficiently close to perceive the precipice. The next 3 months will be pivotal, encompassing the Mars imagery, the perihelion passage, ongoing gamma-ray investigations, its December reappearance, trajectory measurements, and the analysis of UAP data. Each piece of information will either contribute to resolving the puzzle or further complicate it. By the time 3i/2025, TATOS passes Jupiter in March, and the Juno spacecraft has an opportunity for observation, we will possess a considerably clearer, though not entirely complete, picture. Should the object continue to defy explanation by then, maintaining a rating of 6 or higher on the LOE scale, any enforced silence will be broken. The questions will become too insistent, the data too compelling, and we will be compelled to confront the possibility that, as suggested by the 4chan leak, this is not a failure of our models, but rather a glimpse into something fundamental beneath them, something previously unrecognized. Whether that underlying element is exotic astrophysics, dark matter, ancient cosmic remnants, or something entirely novel, we are on the verge of discovery. The universe operates with immense patience. It does not hasten, but it also does not conceal indefinitely. If 3i/2025, TATOS harbors a secret, if there is unseen machinery at play, it will reveal itself through the accumulated data, through meticulous observations, and through the gradual convergence of evidence that either confirms or refutes its extraordinary nature. Our role is to observe, to wait, and to remain open to following the data wherever it may lead, even if that destination is unsettling. For science itself is not a collection of answers, but a methodology for formulating more profound questions. In 3i/2025, TATOS is posing the most significant question we have encountered in a considerable time. What are you? Thus, we arrive at the conclusion of a narrative that remains incomplete. October 3rd, 2025. The Mars flyby concluded mere hours ago. Data is actively being transmitted, and within that stream, perhaps lies an answer, or at the very least, the genesis of one. Let us pause and reflect on what has been presented. 3i/2025, TATOS, an interstellar visitor, marks the third confirmed object of its kind. However, unlike its predecessors, this object exhibits behavior that defies conventional understanding. It vents approximately 150 kilograms per second without any measurable recoil. It possesses a mass comparable to that of a small moon, yet is condensed into a volume no larger than Manhattan. It emits nickel in a state where it should be frozen solid at observed temperatures. Its spectral analysis reveals nickel tetracarbonyl, a synthetic industrial compound. The dust particles it disperses exhibit polarization characteristics so extreme that scientists initially suspected instrument malfunction. It does not appear to rotate, or if it does, its luminosity remains constant. It absorbs gigawatts of solar power, yet maintains a remarkably low temperature. Furthermore, its trajectory, its timing, and its alignment with planetary orbits fall within probability ranges that challenge statistical norms. 7 distinct anomalies have been identified, 4 potentially explainable by known phenomena, and 3 that persist regardless of the data collected. Then there is the leak, an anonymous post purportedly from an individual associated with the European Space Agency, detailing the impossibility of reconciling this object with any known natural entity. It describes chemistry that should not exist on a celestial body billions of years old, dust particles that appear manufactured, and a thermal budget that fails to balance. It concludes with a discouraged yet compelling hypothesis that this is not merely debris, but perhaps a cue ball, a macroscopic quantum object originating from the Big Bang, a bubble of alternate physics encased in ice and dust, slowly decaying over eons. Such an object would possess an internal engine independent of solar influence, producing exotic chemical byproducts as exhaust, with a symmetrical, violent outgassing yielding zero net thrust. This concept, sounding like science fiction, is, according to the leak, the only framework that coherently integrates all the observed data, the sole physical model that transforms a series of anomalies into a unified whole. Critically, it is testable, offering two straightforward, falsifiable predictions. First, observe the object as it departs the solar system. If its activity remains elevated irrespective of its distance, this would be a primary indicator. Second, direct a gamma-ray telescope towards it. The detection of a non-thermal, high-energy signature would provide corroboration. Both predictions are slated for verification in the coming months. Adding another layer is the concealed temporal window. In 26 days, 3I/2025, Tatos will disappear behind the Sun. Perihelion occurs on October 29th, presenting an ideal opportunity for a maneuver, should such actions be feasible, or for the deployment of probes, if they exist. We will observe none of this directly until December, when the object reemerges and we can analyze its trajectory for any alterations. The decoy theory introduces a further dimension. The comet might serve as a diversion, a conspicuous spectacle drawing attention, while genuine reconnaissance is conducted closer to Earth. The Galileo project is actively monitoring for such activity. 3 observatories are scanning the skies for an increase in unexplained phenomena coinciding with the perihelion passage. If such activity is occurring, the data will confirm it. Beneath the surface, the scientific community is experiencing a subtle fragmentation. This is not occurring in public forums or official announcements, but in more private exchanges. Some maintain the object is an unusual, yet natural, comet. Others, confronted with the data, find it irreconcilable with known natural bodies. This cognitive dissonance, according to the leak, is becoming a professional challenge, amplified by an increasingly conspicuous silence from leadership. A proposal has been put forth, UNCIO, the United Nations Committee on Interstellar Objects, designed as a framework for international collaboration. This framework includes the LOE scale as the official classification system, protocols for rapid response, integrated observation networks, and even spacecraft prepared for immediate launch upon the arrival of the next interstellar visitor, as the Vera C. Rubin Observatory guarantees such arrivals will occur, potentially one every few months, or more. Each encounter represents either an opportunity or a warning. 3I/2025, Tatos is currently assigned a rating of 6 on the LOE scale, sufficient to warrant serious investigation, but not yet triggering emergency protocols. However, if the predictions hold true, if gamma rays are detected, if the trajectory shifts, or if its activity persists, the rating will increase, and the discourse will escalate. We stand on the precipice of significant revelations. In the next 3 months, or perhaps sooner, data will emerge that will either validate the conventional explanation or compel us toward alternative paradigms. The Mars images will reveal the nucleus's size, whether large or small. Spectroscopic analysis will refine our understanding of its chemical composition. December's trajectory measurements will indicate whether any significant event transpired behind the Sun. Gamma-ray searches will either yield a detectable signal or definitively rule it out. The Galileo project will either register a spike in UAP detections or it will not. By spring, when 3I/2025, Tatos traverses Jupiter's orbit and the Juno spacecraft obtains close-up observations, we will possess a comprehensive dataset sufficient to determine with a high degree of confidence what this object truly is, or at the very least, what it is not. The universe does not deceive. Its secrets are not concealed indefinitely. If 3I/2025, Tatos is merely an unusual but natural comet, the data will converge towards that conclusion. Anomalies will be resolved, models will be adjusted, and we will move forward. However, if the data continues to resist conventional interpretation, if each new observation adds another layer of strangeness, and if the pattern of anomalies deepens and persists, then we must follow where it leads, even if the path is disquieting, even if it challenges our fundamental understanding of what drifts through the void between the stars. For this is the promise of science, not comfort or certainty, but truth, however unconventional it may ultimately prove to be. Thank you for your attention and for accompanying this narrative through its complexities and its challenging questions. If you found this content valuable, please consider liking this video and subscribing if you haven't already, as it significantly aids in its reach. In the comments section, please share your thoughts. Are you convinced this is simply a comet, or do you perceive something that doesn't quite fit? What do you believe we are observing? This presentation is intended for entertainment and educational purposes. The views expressed herein, particularly concerning the 4chan leak and speculative hypotheses, do not represent established scientific consensus. For verified information, always consult peer-reviewed literature and official statements from space agencies. Until our next encounter, continue to gaze at the skies, for something is indeed traversing the darkness. And in the coming months, our understanding of its nature will undoubtedly expand. Good night.